Hello and welcome to this YOW 2020 interview. My name is Aino Corry and I'm part of inviting the speakers for the conference. I'm very happy today to have Felienne Hermans, an associate professor who's also going to speak at YOW 2020 with me in this interview. Hello, Felienne.
Hi.
Good to see you. And I am intrigued by the book you're writing at the moment. It's going to be published by Manning very soon now. And I had a chance to read a little bit in your book yesterday. And what I got out of it was it's not necessarily because somebody is stupid that they don't understand the code that you've written so brilliantly. And I really like that takeaway from the book, that you're not necessarily stupid just because you can't read somebody else's code, because there's so many things going into it. And I'd like us to touch on a few of them and then you'll elaborate more at the conference. But the first example in your book was a bit of code that was written in APL and Java and BASIC. And then you asked the reader to try to understand these bits of code. And then afterwards you explained to us why it was difficult to understand different parts of this code. Could you elaborate on that different kinds?
Yes, absolutely. Firstly, I'm very happy with your takeaway of the book. I couldn't have said it better. I don't think I say it in these words. So I'm very thankful already for you saying that, yes, if someone doesn't understand your code, it's not always about them. It can also be about your style, but it can also be just a lack of knowledge on the part of the reader, which of course doesn't mean that they're stupid. It just means that they don't know yet. So you mentioned APL as an example. So people aren't familiar with APL. You should Google this before you listen to the rest of the interview. APL is a programming language that has keywords that are all one symbol. So it doesn't have something like for or while. All of them are really weird mathematical symbols. So if you don't understand that, it's a problem of knowledge. You just don't know what the keywords mean. It isn't because you cannot follow the code. You could follow the code if you would just have a little bit more knowledge. Whereas in Java, understanding Java code isn't necessarily about lacking knowledge. Probably you know what the keywords mean. If the code is written about a domain that you're also familiar with, you might know the domain concepts also. So it isn't necessarily knowledge that you are missing. It's more missing information, because Java code can be very much structured. You have classes, you have methods, and the methods refer to each other, maybe to different classes. So sometimes reading code in an old language like Java can be a little bit like a scavenger hunt, that you have to find the right information. So that's a different kind of confusion. That's a different kind of having trouble with reading the code. It isn't about you not knowing things. It's about you not having easy access to the right information. And then if you think of canonical basic code, maybe the code that you read or even wrote when you were maybe a teenager learning to program, then in basic, if you read those old basic programs, often they don't have great variable names. They don't have abstraction, they don't have methods or subroutines. It's a very long list of lines. And there's yet another type of confusion, because if you have to read basic code, and this can also happen in Python code or Java code, sometimes you notice you using your finger, right? You take your finger to the screen and you point at the variable, and then you're like, oh, this variable, where else does it occur? Maybe you use Control F a lot to search through the code. That's not so much a problem of missing information. That's a problem where your brain is too limited. You lack processing power to really hold everything that happens in your mind. So as soon as you start using your finger on the screen, or maybe scribbling intermediate values of variables, that's a different kind of confusion. And in my book, I talk about these different types of confusions in terms of cognitive processes. So the first one, the APL, there you really have an issue with your long-term memory, because your long-term memory doesn't know the keywords. Whereas in the basic example, you have an issue with your working memory. Your working memory is too full and you cannot really process more code. So the book details that in a lot more detail.
Yes, and I really like that you're using that conceptual model of the brains, because you sometimes when you're thinking that people are stupid, it's just because you don't know that they're only using the RAM part of their brain and not actually the real memory. And you can't really compete with those two things. They're so different that you can't compare them like that.
Yeah.
You talk about reading code faster, and in reading code faster, you mention again this conceptual model of the long-term memory and the short-term memory and the working memory, the processing power. and you talk about the difference between an expert and a novice and the way the brains work differently in an expert and a novice. Could you come with an example of how this works?
Yes, I think the closest example could be reading natural language. My native language isn't English. My native language is Dutch. So if I read Dutch, then that will be a lot easier for me still than reading English. And then English will still be easier for me than maybe reading something like Greek, where I don't really know the alphabet. So if I'm reading Greek, I will also use my finger. I will be like alpha, gamma, beta. I have to spell out the letters one by one. And I'm also almost like behaving like a 5 or 6 year old, right? So if you have a 5 or 6 year old, or if you've raised one, and you know that if they're learning to read, they also do this. They're like C-A-T, cat, in, tree. So the fact that I show that behavior in Greek, it doesn't make me as stupid as a 5-year-old, right? It's just because the context I am in now, I haven't had enough practice and training, and I haven't stored the Greek letters in my long-term memory well enough to be able to quickly recognize them. And then of course the basics is letters, but then you also have word parts that you can quickly recognize. So you see that in a different context, you show childish behavior in a cognitive sense. So in the book, we also talk about 4 different levels of behavior. And there's quite some research that says that exactly what I just explained, that if you go to a new context, then your behavior starts to be almost childlike. And again, as I said, I really like your summary. That doesn't mean that someone is stupid. It just means that they haven't had enough practice. So you might also see this behavior in yourself, or maybe in some junior team members, where you're like, this is otherwise a smart person, but then I expose them to this piece of source code, and suddenly it seems like they aren't smart. It seems like they're maybe not smart. And what I like people to take away from my talk at YOW, but also what I like people to take away from my book, is that it isn't because they don't know things. It is because they haven't practiced. They don't have enough long-term memory stored that they can use, that they can apply on this problem. One of the things we talk about in the book is called chunking. And chunking is the idea that certain parts of knowledge from your long-term memory really come in handy if you read or write something that at the expert level. And for example, in reading natural language, letters and words are chunks that you can use to read. In Java or in Python programming, a for loop or an if statement is something that if you're an expert programmer, you don't read if A = B, space. You at once, you see, oh, this is statement. This is the condition, this is the if branch, and this is the else branch. It doesn't take you any effort to read that. Whereas a beginner in the domain or a beginner in the programming language might in fact still need a little bit of processing power to figure out what an if is. And then especially if you have more advanced programming concept like a ternary operator, for example. A ternary operator also is an if. So a person that might really know programming and might be conceptual very familiar with an if statement, once they're exposed to a ternary, they're more like the order is different. It is the value and then the condition and then the else value. So then a lot of cognitive energy is spent on reading the unfamiliar language concept. And then again, your brain gets so full that you then cannot see the forest for the trees.
Yeah. And I think it's interesting to communicate about natural languages when you talk about programming languages. I remember when the Java came out and Java virtual machine, I was trying to understand it conceptually. And the way the theory I made around it was, now your mother tongue is Dutch and my mother tongue is Danish, and we communicate in English. And in a sense, I think the Java virtual machine is like English, because we have to make small programs that fits the Java virtual machine so that you can understand it on your computer, right, on your brain. And that means that when we communicate constrained by that virtual machine. That is what we understand of English. So we can only communicate in what you understand that is put together with what I understand in English. So for instance, if we were to do this interview in Dutch or Danish, it would be like C++. We could go directly to the metal, right? And we could make use of the whole hardware, but we're constrained to a virtual machine when we're communicating in this third language.
Yeah, I think that's yet another great interpretation of the things that we're doing, that we have a chapter in the book about refactoring code to like lower the cognitive capabilities a person needs. For example, like I just said, if you have lots of ternary operations, you might want to temporarily transform them into traditional if statements for readability. And then I know this upsets some people because they will say, yeah, but ternaries are shorter and shorter is always better. But it isn't always better if the other person doesn't understand that. So indeed, you have to find a common ground. And maybe that means not writing ternaries for a while, or maybe that means when you're really digging into a specific code with someone that is junior or new to your team, maybe for a while, and many IDEs now just support this out of the box, you can just say, unfold this for now, for this context, we're going to look at the full raw if, and then later we transform it. Just like indeed that we both change our cognitive thinking a little bit because we now have to think in English. So it limits us a bit, but it does allow us to have a conversation where I would answer your Danish questions in Dutch. No one would understand anything. So I think that's a great example. And more evidence actually is showing that programming is very much like natural language. So we like to think in programming that programming is like math, right? Like many universities say these things, like, oh, you need really good calculus skills to program, or many boot camps also say similar things. Whereas new research, there was a Nature paper in March that showed that how good you are at learning a second language is a great predictor for how good you'll be at programming, which is like mind-blowing to everything.
Very interesting.
We believe, right? Because we like to think that if you're good at math, then you're good at programming. And this turns out to be not all that true. It actually turns out that how good you are, how good your working memory is, but also how good you are at learning a second language is a great predictor for programming capabilities. So the comparison that I often make between, hey, a programming language is a little bit like a natural language, cognitively also makes sense. And of course, it is a programming language. It is not a programming math. It is a programming language. So it isn't so weird that languages play a role. There's also research that says that like 70% of code is words. It's keywords, it's variable names, it's method names. So yeah, of course, if you're good with words and 70% of the things you're looking at is words, then surely that's going to help. And of course, some people will say, yes, but there is logic too, if statements and for loops and logic. So you have to do logical reasoning. But using a language is also logical reasoning, because our language is very ambiguous. So you have to fill in gaps. You have to hold two possibilities, two meanings maybe of a word that is can have multiple meanings, and then only later in the sentence you're like, oh, this is what they mean. Like if you say what's a good example of a synonym? What's a good example?
I always complain about the word think. It has three different meanings in Danish. It's like think, there's something you think about. It's think is you think this is correct.
Oh, yes.
You believe, right?
Yeah, that's a great example. So indeed, if I start a sentence with I think, then indeed it can mean I believe, or it can mean I am thinking about something. And only later in the sentence, you will know what the person means. So that is also logical reasoning. That's holding two opinions or two thoughts at the same time in your brain, and it's only being resolved later. Well, that's very, very similar to programming.
Yeah, so if you're speaking German, you don't know what the sentence is about until you get the verb, which is like far, far away from the start, right? I don't know if it's the same in Dutch. It's definitely...
Yeah, you can do that, although it's getting a little bit out of fashion. So if you do it now, it's likely that you're above 50, but it's definitely something that the language supports, let's say, out of the box.
Right. I think I wanted to ask you a question in Danish, but I think I'll wait till the end and people can just shut down the interview. But there's one thing that I really liked about this this next chapter I read, which was about how to get some empathy into the onboarding process. I particularly liked that research shows that comments are good. I've been teaching programming for so many years, and I have all these very clever students who say, you just read the code, that's enough. It should, and they don't, and they actually sound like that when they say it. So I really like that that you can actually with research prove that comments are good. But there are other things as well. They're like naming conventions, code standards, the things that we've been talking about that people have been saying is not necessarily a good idea. And I think all these things are really interesting. So, but then there was the deliberate practice, which I also found interesting, where you say that it's not just writing a whole lot of code, but it's deliberately practicing things. And do you think it's the same as code kata that people might know about already?
Yeah, so first let's maybe explain a little bit more what deliberate practice is and how we know that it works. So deliberate practice is indeed practicing small skills, and lots of research shows that that works well, for example, especially research on sports and research on music. So we researchers, not me personally, but research has studied, for example, expert violin players. So they compared expert violin players to still good violin players. They were all studying music, but then the expert players, they wouldn't just practice a little bit during the day. They would really set apart 2 hours, and they would specifically find a piece of music that they found really hard, and they would practice that. They would study it. They would say, why is this so hard? Oh, because it's in the key of F that I haven't practiced so much, so I'm specifically going to practice that. And it turns out that that really, really works well. And the same is true for sports. If you're a great tennis player, then also you're not just going to say, oh, to get better at tennis, I'm just going to play a tennis match. No, you're going to say, oh, my backhand, if the opponent is on the left side of the court and I'm on the right hand side, then this is where I always fail in my backhand. You analyze games and you see, this is what I want to get better at, and then you practice it. So in programming, it doesn't seem like we really in a state where this is the case. So coding katas is an interesting example, because indeed coding katas are like deliberate practice, although I think it could be a little bit better, because coding katas often are, if they're done in a group and then together we're going to implement a little program, but it isn't necessarily that's where you're lacking. So what you maybe first want to do is understand, what are the things I'm finding hard? So I just in the beginning of the interview gave the example that maybe you would want to rewrite a ternary operator to an if, because that's where you're struggling. Then that should go somewhere. We have some tricks in the book also, somewhere on the list of, this is something I should deliberately practice. And then katas, even though I like them, are still focused on writing code. So there's still the assumption that writing code is going to make you a better coder, which I'm not saying is not true, but it's definitely not the only way. So if you're struggling with, let's say, ternary operators, you think they're really hard, then what you could also do is just write 100 ternary operators and then rewrite them to traditional ifs, or the other way around, which isn't producing code in the sense that kata is still producing, let's say, sensible codes. Whereas, again, think of a violin player. If they do 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 do, that's not a piece of music. That's a piece of practice. So I think katas could be appended with exercises where clearly you're not writing real code. You're just practicing, you're doing a tone ladder for code. So I definitely think they're in the right way, but you could also do this in a more deliberate way. And then it doesn't even necessarily have to be writing code. So maybe some people that have learned a second or third language are familiar with using flashcards. So flashcards are like, you have a post-it and on one side you write Dutch and on the other side you write English. And then you just put them on the table and you take a random one and you read the English and you're like, do I know the Dutch? And then you flip it over, you see if you were correct. This is also a technique which we cover in the book, which can be very, very valuable for programming. Again, ternary operators or other, let's say, more advanced programming concepts like lambdas or list comprehensions. If you're struggling with these advanced concepts, you can make a deck of flashcards where you put on one side the list comprehension and on the other side the regular loop that's the equivalent. You take one and you're like, do I know how this would look like as a list comprehension? And you flip it around. And you can do this on a physical piece of soft paper, but there are also apps where you can use flashcard training. And this is actually something that we're doing with students at Leiden University. We're having them practice Python with an app where they're not writing Python, we're just giving them programs and we're asking them, what would this do? What is the outcome of this? Practice reading. And then they can flip the virtual card to see if they were right.
Very good. So when you make that connection between natural languages and programming languages, there's actually a whole plethora of learning tools that you suddenly get for programming languages. That's really amazing.
Yeah.
So I remember people talked about that people really want to learn how to program. So they program, but what they forget sometimes is to read good pieces of code. Like if you want to be a writer, you will read the classical books, you will read the good books that everybody looks at and say you should read, like Shakespeare or what, I can't remember any authors right now, but you know what I mean.
Yes.
Is that something that would be helpful as well? And
yes, definitely.
Those good pieces of code, like the C compiler, is that a good piece of code? What?
Yeah, so there are a few books actually that indeed cover famous pieces of source code and discuss them a little bit. So I definitely think that is a good approach. And then I would say even more so, if you're really studying literature, then you aren't just reading Shakespeare. You are analyzing Shakespeare. And there is a chapter in the book as well, which you haven't read, but maybe you guessed which direction I'm going in, where we say, read a piece of code and then answer these questions. So with a piece of Shakespeare, you might say, hey, how did that part make you feel and why? What are the techniques that the writer is using there? And this is also very valuable for code. And I've actually been practicing this, where in some companies I've been running what we call code reading clubs, where we do exactly this. So the group of professional developers, they take a piece of source code. This can be from their own code base, or just often we just randomly grab something from GitHub. And then we say, okay, in this code, what is the most important line and why? And then you see that there are different opinions and you can learn from each other. These skills of what is the most important line? What was and this can be sarcastic, but also that serious. What was this person thinking while writing this code? Can we understand why the decisions were made the way they were made? What could have been alternative decisions? So it's not just about reading good code, like reading a book, which might be a little bit weird for code, but sit down by the fire with a glass of bourbon and read some C kernel would be a bit weird. But reflecting on what is going on there, why would someone make the decision? And also sometimes, like with Shakespeare, historical context can matter a lot. So many decisions that were made in the Linux kernel, for example, we might not do it like that now, but that's because now any computer has multiple cores, for example. So there's definitely a little bit of historical context where we say, well, the hardware was different, or certain language concepts just weren't mainstream. So clearly, you could look at the Linux kernel and say, hey, why didn't they use a lambda? Or why didn't they use a for loop? Or why didn't they use this or this or this or this? But not everything was either available, was either mainstream, was going to be a good idea on the certain hardware that they had at the time.
Yeah, the context is really important.
Yeah.
And the things that were good, that worked in that context might not work in a new context like that.
Absolutely, yes. So sometimes there's things you can take away to a different code base. Sometimes there are also things you can take away, like, I see why they did it, but we don't do that, or it's not a good idea, or in Python it would never work like that, which also is still a good lesson.
Yeah, definitely. So the second, the penultimate question is, you talk about beacons, that you should leave beacons in the code for the readers. What do you mean? Little lights? How can you put a beacon in code?
Would be nice. So yeah, there isn't like a great formal definition of beacons because different authors use slightly different definitions. But I think that the most intuitive thing is if a certain piece in the source code makes you go, now I get it. That is a beacon. So this can be a variable name, a well-chosen variable name, or a well-chosen method name can definitely be a beacon. Think of, you have a function that's called calculate or analyze or get data. We've all seen these functions. Then that is not going to be helpful. If you have a function that is called analyze, then the burden is on you to figure out what is going on. And then, you bring out your finger again with reading. So a method name can definitely be a beacon. But comments, this is what you're hinting at, I think. Comments can also really serve as beacons. So sometimes you read a comment and the comment is unlocking the understanding. You read it and maybe the function is called analyze, but on the top it says this is calculating the maximum interest rate on mortgages or something. So then from the comment you're like, now I get it. And we've seen in research that especially expert readers make heavy use of beacons when they read code. So a beginner programmer, again, think of a 5-year-old, a beginner programmer will be like, reading, looking at all the parameters, trying to piece everything together, where a more expert, experienced programmer just scans code, sees something that's very familiar to them, like a domain concept or an if then else that looks like something they've seen before in this code base or something else. And then they're like, now I get it. So leaving beacons in the code, thinking of what could someone think while reading this code. But also if you are reading codes and you're struggling, maybe at one point you get it, right? So you're reading this code and you're like, now I see. That would be a great moment to think, hey, can I reproduce this thinking that I just did in a comment, a better variable name, a restructuring of the code in a way that the goal of it is more clear, and leave those breadcrumbs for future you or future colleagues that are going to read the code.
Yeah. Think about the one who should read this code, especially you in 3 months.
Yeah.
So, thank you very much, Felienne. I would like to conclude this interview with pointing forwards towards your YOW presentation in December. So could you tell us what can we expect to understand when we hear that talk?
So it will basically be this interview in more depth. So we will definitely going to look at some code. So then in the talk, of course, I have the benefits of having slides. So I can show you confusing slide examples. Maybe I should have a warning in the beginning of the slide, like, warning, this could be traumatic. I will show you terrible code. So I will show you like, this is incomprehensible to almost anyone. Why is that the case? What cognitive processes are at play here? So we got definitely going to zoom into these 3 different types of confusion that we talked about early in the interview. And then we will also talk about techniques, mainly the things we also just briefly hinted at, reading code with specifically this is called adjunct questions. So have leading questions to guide your understanding of a piece of code, refactor for comprehension. What are code concepts that people typically think are difficult and how could you refactor this to make it more readable? That's the type of thing we're going to talk about in the talk.
That sounds great. Thank you, Felienne. And now, have en rigtig god dag.
Fijne dag nog.